One great way to spice up your stuffed animal or hat or any other e-textiles project you have is to embed or add smart RGB LEDs like this one. A smart RGB LED is an LED that you can program to change colors, and one of the most popular is made by Adafruit. That's the one I'm showing you right now. They call theirs the Neopixel, and if you look online you'll see tons of projects that use Neopixels. They're a great product. I love the quality of the color that comes out of it, how true it is, how bright and how well they mix. But one of the problems with the Neopixel is it's kind of expensive. This one here is a couple bucks. So if you wanted to add a bunch of these to one of your projects, that would add up pretty quick. So to save a little bit of money, I've developed my own breakout board for a slightly different chip. I call mine generically the Smart Sobel RGB LED. This is the first version, and if I flip it over, you'll see that it uses the SK6812. It's a little bit hard to read there, but that's the Smart RGB LED chip that I use, and it's compatible with the Neopixel one, so you can actually use the exact same code. To get started, you're going to need a SK6812, so I'll cut one off of my strip here. And then to get that out of there, I'm gonna grab one side with some pliers here so that my fingers aren't taking up too much of the window space here in the camera. And I'm gonna peel off the plastic with some tweezers. You're gonna need tweezers to do this project. So before we start solder, I want to point out a few things. Surface mount soldering is much more of a trick than through-hole soldering. So the surface mount just means that there's no hole that we stick a pin through and then solder. Everything's just soldered on one side of the board. So before we start, I'm going to flip this board over and just point out that there are some metal pads. There are 4 metal pads on the back of this board, and they need to get soldered to these 4 metal pads right here. This project is a pretty good beginner project for surface mount soldering because we only have those 4 pads plus 2 up here for a resistor and 2 down here for a capacitor. So it's a pretty minimal project. But like I said, it's a little bit of a trick. I'm going to go ahead and flip this guy back around and show you one more thing that we need to pay attention to. And that is, if you look in the corner right here, you'll see there's a little white corner. That white corner needs to line up with this dot over here. If I orient my SK6812 any other way, then it's not going to work. So what I'm going to do is put a little bit of solder in this pad right here. It doesn't really matter which pad I do, but I'm just going to put a little bit of solder on one of these pads, and that's going to allow me to fix the SK6812 in place so that I can solder the other 3 pads. Before you start, you're going to want to have your soldering iron turned down quite a bit. So I'm soldering with tin, a non-toxic solder, which typically I solder at 700 degrees. But for surface mount soldering, I turn the temperature down. I turn the temperature down to 650 degrees Fahrenheit, or about 340 degrees Celsius. All right, so I've tinned the tip of my soldering iron. Now before I start soldering, I'm going to put a little bit of flux on each one of these pads. And then a little bit of solder on just one of the pads. You can see I got a little blob there. Next, I'm going to grab the SK6812 with my tweezers and position it exactly in the right spot. This can take a little bit of time. It's pretty tricky, but positioning is the most important part of soldering these surface mount components. If you don't have them positioned right, it's not going to work. Now that I've got it positioned, I'm going to move my soldering iron into that pad and I'm going to heat it up. So now that it's a liquid, and I'm pushing down with my soldering iron to hold the breakout board, the circuit board in place, and then I'm pushing down with my tweezers on the SK6812 to hold it in place and the circuit board. And you can see I've got a little too much solder here. See the little horn there? So what I'm going to do is I'm just going to heat this up again with my soldering iron, and I'm just going to keep drawing away and then cleaning my iron in my brill until eventually I'm going to pull away, and hopefully there won't be a horn there. We'll see. And I'm always pulling away because I want to connect those pads. Now if I look at my circuit board from the side, you can see that connection. It's a nice little piece of tin connecting the metal on that SK6812 to the pad on the circuit board. We want to make all of our other pads look just like that. So now I'm going to tin the tip of my iron again to get it nice and silvery. So I'm going to melt a little solder on there. And then I'm going to put that in my brill and just spin it around until my soldering iron is nice and silvery. So it looks a lot more silvery now. And then I'm going to do the same thing on the other side. I'm going to hold the SK6812 down with my tweezers, and I'm just heating those two pads up, and I keep cleaning until there's just not too much solder there. It's time for the last one now. Again, got to keep the tip of the iron nice and silvery if I want it to work well for me. That's actually more important with the surface mount soldering. And I'm going to put a relatively small bead on here because I don't want to have to pull so much off. I'm twisting my iron around so that that bead hits the board first, hits those two pads first. Just touch it right on there. Pull off. Still don't have too much, but just a little too much. And I think that that's good. Let's take a look here. Yeah, you can see that's a nice connection there. All right. Now the next step is to get the next piece. And in this video, you'll notice that when I'm soldering surface mount components, I only get one piece at a time. And that's because the pieces are so tiny that if I get more than one piece at a time, I'm likely to lose them. So I'm going to just get this capacitor here. My capacitors I intentionally bought yellow ones so that I could easily tell them apart from my resistors. This is a 0.1 microfarad capacitor, and the physical size of it is 0.805. There are lots of different sizes of surface mount components you can get. 0.805 is a nice compromise between small enough that it fits nicely on our board, but large enough that it's relatively easy to solder. So to solder this component, I need to put some more flux on the capacitor pads right here. And then I'm going to put just a little bit of solder on one of those pads. Now that I have a little blob of solder on one of the pads for the capacitor, it's time to solder it into position. I'm going to put my iron right next to the blob and push down on the circuit board and then roll towards it. And that allows me to kind of keep that circuit board from moving so that I can put my capacitor into place here. Again, positioning this is pretty critical and pretty tricky. Once you have it in position, I just use one side of my tweezers to push down to hold the capacitor in place. And I pull away with my soldering iron. And I have too much solder there, you can see by the little horn, so I'm just going to heat it up again. Make sure I'm touching both the pad and the resistor. And I'm going to pull away a couple times until I get enough of that solder off of the board that it doesn't leave a horn behind. Now if we look at that connection, you see a nice bridge between the resistor and the metal pad underneath. It's not perfectly centered, but it'll work. Now it's time to get the other side. Again, I'm tinning the tip of my iron to keep it nice and silvery, cleaning it in the brill. It's nice and silvery now. Get a tiny little blob of solder on there. And now I'm gonna, before I do anything, I'm gonna put the tweezers on the capacitor and hold it down in place, because when I put my iron in here, it's gonna heat up the capacitor so much that it actually melts both sides, solder on both sides here. Now I pull my soldering iron away, and we can see that that connection is also a nice smooth connection between the component and the board. Now it's time to add the resistor. Here I have a spool of 300 ohm resistors that are the same size as the capacitor. I'm going to use my tweezers to pull that plastic off. Before I do anything with solder, I'm going to put some flux on those pads. I'm going to put a little blob on my soldering iron and then twist it around in the brill. And then I'm going to touch the iron to that pad to put a little solder on one of the pads. Then I'm going to heat that up and put my resistor into place. Push down on it with my tweezers to hold it in place as I pull my iron away. Oh. And then I'm going to put a little bit of solder right on the other side. Before I add the solder, I will use my tweezers to hold that resistor down in place. I'm going to touch both the resistor and the pad with my iron. And then clean it up. Just keep touching it and cleaning it until the excess solder is gone.